We are moving our way through section 11.2. We've looked at simplifying radicals, we've considered the presence of variables, we've learned how to multiply radicals, so now let's talk about dividing radicals. We're not going to be doing so much of dividing radicals, but we need to consider some rules, some properties about what happens when you have fractions with radicals involved. If I have a radical in a denominator, what do I do? So let's first look at the quotient property. Very similar to the product property, but now with division or with a fraction. When I have a fraction underneath a radical sign, so I'm looking at the square root of a over b, I'm allowed to break them into numerator and denominator, each with their own individual radical sign. So the square root of a over b becomes the square root of a over the square root of b. But we have to consider these next two rules. Now, when I first introduced radicals to you, we talked about the rule that a simplified answer cannot contain any perfect square factors under the radical sign. That's rule number 1. We have rules 2 and 3 right here. I cannot leave a fraction underneath a radical sign. So the first part of my quotient property there, where I have the square root of a over b, is not simplified. So it would need to be broken up into radical a over radical b. I also cannot have any radicals in the denominator, ever. No radicals in the denominator. So if I had root a over root b, I would have to do something about that too. I'd have to consider what step I could take to get rid of a radical in the denominator. That's coming in just a minute. Let's first just look at if we had a fraction underneath a radical sign, what I would consider doing. This is just going to be straight application of the quotient property. So if I had the square root of 5 over 49, I'm going to break it into its numerator, denominator components. So as I said above, I cannot leave the square root of 49 in the denominator. However, I know that the square root of 49 is a perfect square. 49 is a perfect square, so I'm going to make this into square root 5 over 7. Let's take a look. That's simplified in the numerator. I've got an integer in my denominator. This is done. So square root of 5 over 7 is your correct answer. Second example, try it yourself if you'd like. Hit pause. Let's continue. We'll break it into numerator, denominator. Root 11 is simplified, but let's consider my denominator. And since it's an even exponent, it's a perfect square. So I'm going to simplify my answer. I'm going to make it the square root of 11, over x squared. And we're done. So that's what happens when you have a fraction underneath a radical sign. You're going to consider simplifying the radical. The next step is tied in with this. This is going to be a process called rationalizing the denominator. Take a look at my first example, 7 over radical 6. So there's no fraction underneath a radical sign, but I have a radical in the denominator here. That's a problem for us. If I go back up, remember our rule number 3 was there's no radicals in the denominator. So the process is called rationalizing. Rationalizing is going to guarantee that I don't have a radical in the denominator. And the only way I can guarantee that is to multiply radical 6 by radical 6. But based off of everything you've learned so far in algebra, I cannot just do that to the denominator. If I'm going to do that to the denominator, I also have to do this to the numerator. So why am I allowed to do this? Why am I allowed to take root 6 over root 6 and multiply it by this expression out of nowhere? Well, the value of this over this is 1. Multiplying anything by 1 doesn't effectively does not change its value, but it's going to allow me to put this in a simplified form. So when I multiply radicals in my numerator, I get 7 root 6. And in the denominator, root 6 times root 6, now we learned in our previous lesson that this will give me root 36, but anytime I have a radical multiply by itself, it just gives me that value that's underneath the radical sign. So if you want to jump ahead and just write this as 6, that's what I would do. Let's take a look. Root 6, no perfect square factors. 7 over 6, I can't simplify, do anything with that, so this is complete. That's done. That's successfully rationalized the denominator. This one is going to have an extra step or two, so I'm going to try this one more time. Now I have 2 over 3 root 10. So there's almost like a coefficient in front of the radical sign right here. So to rationalize here, you don't have to rationalize by the entire denominator here. I would do just root 10. And remember, we have to do it to both the numerator and the denominator. This new factor I have created has a value of 1. So numerator, I got 2 root 10. Denominator. Now, you have to consider 3. Root 10 times root 10 is 10. 10 times 3 is going to be 30. Let's take a look at this. Root 10 does not have any perfect square factors, but 2 and 30. Now, this is going to be like an expression, almost just like a fraction. You would not leave 2 over 30. They're both even numbers. They're both divisible by 2. So we're going to reduce this. We would cut both of them in half to make it 1 over 15. So since I don't need to write a 1 in front of the root 10, my final answer here is going to be root 10 over 15. So that's the simplified form of the expression that was given over on the left.